students, in this lecture we will study about indices and logarithms. Indices is the plural of index, which means power or exponent. So power, exponent, index, these all have the same meaning. So what is index or what is exponent? For example, we have got a number m. Say we are given a number m. So this number, the exponential form of this number m, is given by b power n. b power n. So that is the base. B is the base and n is the power, or also called exponent or index. This n is the index, power or exponent of b. So this whole b power n is the exponential form of this number m. Restriction is there. This base b is greater than 0. Base b is greater than 0 means positive, and this base is not equal to 1, because if this base is equal to 1, so 1 power something is 1. So this exponential form vanishes there whenever b equals to 1. Anyways, b power n is the exponential form of m, a number m. For example, in this equation, this b is the base and this n is called the index, power or exponent of b. So b is the index, power or exponent of b. For example, b square. So b is the base and 2 is the index or power or exponent. B square means b multiplied by b. Whenever you multiply b with b, so that will become b square. Similarly, if we multiply b 3 times, so that is b cube. And similarly, if we multiply b 4 times, so that is b power 4. So b power 4, b cube, b square, all these are the exponential forms. For example, if b is 2 and that is the power 2, so 2 power 2 can be written as 2 multiplied by 2. When we multiply 2 2 times, so that will become 2 square. So 2 into 2 is 4, 2 square is 4. So it means that the exponential form of 4 is 2 square in this sense. In this case, m is 4 and b power n is 2 square. So the exponential form of 4 is 2 square. Similarly, we have taken a negative number here, minus 2, minus 2 power 3. It means that minus 2 is multiplied 3 times. Whenever we multiply minus 2 3 times, so that will become 2 2s are 4, 4 2s are 8, so that is 8. And whenever negative sign is multiplied 3 times, odd number of times, so that will become minus. Just look at here, minus into minus is plus and plus into minus is minus. So minus 2 whole cube is minus 8. So we may say that the exponential form of minus 8 is minus 2 whole cube. Similarly, 2 power 4. 2 power 4 means 2 is multiplied 4 times. Whenever we multiply 2 4 times, so that will become 2 2s are 4, 4 2s are 8, 8 2s are 16. So 2 power 4 is actually 16. We can say that the exponential form of 16 is 2 power 4. Similarly, from this definition, b power 0, any number to the power 0 is 1. For example, if we have got 2 power 0, so 2 power 0 is 1. Similarly, 3 power 0 is 1. 4 power 0 is 1. So number to the power 0 is 1. And the seventh one is, if there is a negative power of b power minus n. So b power minus n can be written as 1 by b power n. Whenever we shift this b power minus n in denominator, so the power will become positive. Whenever you shift this b power plus n numerator, so that will become negative. So shifting a number from numerator to denominator or from denominator to numerator will changes the sign of the power. For example, if we have got 2 power minus 2, so 2 power minus 2 can be written as 1 by 2 power plus 2. We shift 2 power minus 2 in denominator, so that's why this negative sign will become plus sign, and 2 power 2 can be written as 2 multiplied by 2. 2 multiplied by 2 is 4, so 2 power minus 2 is 1 by 4. So you may say that the exponential form of 1 by 4 is 2 power minus 2. Similarly, if there is 3 power minus 3, 3 power minus 3 can be written as 1 by 3 power plus 3, and 3 power 3 can be written as 3 multiplied by 3 multiplied by 3. Whenever we multiply these 3 3's, 3 3's are 9, 9 3's are 27, we get 1 divided by 27. So that is the exponential forms of different numbers. We have got an example here. Example is we are asked to evaluate, to simplify 3 square, 4 cube, 7 power 0, 5 power 1, and so on and so on. So let us start the solution. First of all, we need to simplify 3 square. So 3 square can be written as 3 multiplied by 3, and 3 multiplied by 3 is 9. Similarly, 4 cube means 4 is multiplied 3 times. So whenever you multiply 4 3 times, you will get 64. 4 4s are 16, 16 4s are 64. And the third part is 7 power 0. So 7 power 0 is 1, because any number to the power 0 is 1. So that equals to 1. Similarly, 5 power 1. 5 power 1 means the same 5. And 5 power minus 1. The power of 5 is negative. So shift it towards denominator, so that will become positive. 1 by 5 power 1, and 5 power 1 is 5. Similarly, minus 2 power 6. So minus 2 power 6 can be written as minus 2 is multiplied 6 times. 6 times. 1, 2, 3, 4, 5, and 6. So negative signs are multiplied 6 times, even number of times, so that will become plus. And whenever you multiply 2 6 times, you will get 64. 2 2's are 4, 4 2's are 8, 8 2's are 16, 16 2's are 32, 32 2's are 64. So minus 2 to the power 6 is 64. Similarly, 3 power minus 4, the power is negative, so shift it in the denominator, so that will become 1 by 3 power 4. 3 power 4 means 3 is multiplied 4 times. So 3 3's are 9, 9 3's are 27, 27 3's are 81. So that will become 1 by 81. And h part is minus 2 power minus 3. Minus 2 power minus 3, the power is negative, so shift it in the denominator. That will become minus 2 power plus 3. Minus 2 power plus 3 means minus 2 is multiplied 3 times, so that is 3 times. We see that minus sign is multiplied 3 times, so that will become minus sign. And whenever you multiply 2 3 times, you'll get 8, so that will become minus 1 by 8. And the last part is 1.723 to the power 0. So number to the power 0 is 1, just like the same as in part C. 7 power 0 is 1, so 1.723 power 0 is again 1. So that is the answer of this question, these all parts. So that's how we simplify the exponential form of a number. Now in the coming slide we'll study that what are the laws of exponents or indices, because we have studied that what is exponent. Exponent is also called index, also called power. So laws of exponents or laws of indices, whatever you say. The first law is whenever two exponential forms are multiplied with the same base, the base of these two exponential functions are same, b. So whenever the bases are same, powers will be added, so that will become b power m plus n. For example, 2 power 2 multiplied by 2 power 3, we see that the base is same, so the powers will be added, so that will become 2 power 2 plus 3, and 2 power 2 plus 3 is 5, 2 power 5. Similarly, if there is a 3 power 4 multiplied by 3 power minus 2, as the bases are the same, so powers will be added, so that will become 4 plus into minus 2. Now simplifying these, plus into minus is minus, and 4 minus 2 is 2, so that is 3 square. The second law is whenever two exponential forms are divided with the same base, the bases are the same and the powers are different. So whenever bases are same and those are divided, so that will become b power m minus n. What does it mean? It means that subtract the two powers, subtract the upper power, subtract the lower power from the upper power, b power m minus n. For example, if we have 4 power 4 divided by 4 power 2, we see that bases are same, so whenever we divide these two, we will become 4 power above power minus below power, so 4 power 4 minus 2, and 4 minus 2 is 2. Similarly, we see here that the bases are the same, minus 3 minus 3, and we are going to divide these two, so that will become minus 3 to the power 5 minus 6, 5 minus 6, above power minus below power, and 5 minus 6 is again minus 1. The third law is whenever b power m whole n, whole power is n, or if b power n whole m is there, so we can write these two as in this form, b power m multiplied by n. Multiply these two powers, n cross m or m cross n, whatever, so that will become b power m into n. For example, if there is 2 power 3 whole square, or if there is 2 power 2 whole cube, so these two can be written as 2 power 2 multiplied by 3, and 2 multiplied by 3 is 6, so that is 2 power 6. Number 4, if there is whole power of the multiplication of two numbers, a multiplied by b whole n, so we can separate this power on a and b separately. For example, if we have 2 multiplied by 3 whole 5, so this can be written as 2 power 5 multiplied by 3 power 5. And for example, if there is 4 multiplied by 5 whole power minus 2, so that is whole power. This whole power can be written on 4 multiplied by 5 power minus 2. Now the fifth rule is, whenever there is whole power on division of two numbers, a by b whole n, this is whole power on the multiplication of two numbers, and this is whole power on the division of two numbers. So a by b whole n can be written as a power n divided by b power n. What does it mean? It means that we can split the power on a as well as on b. So that is a power n divided by b power n. For example, if there is 2 by 3 whole 4, so this whole 4 can be written on 2 n on 3. So 2 power 4 divided by 3 power 4. Now simplifying this further, 2 power 4 means multiply 2 4 times, and 3 power 4 means multiply 3 4 times. So whenever we multiply 2 4 times, you get 16, and multiplying 3 4 times to get 81. So that is 16 by 81. And the last law of exponent is, which is very much important, the sixth one. If we are given a power x is equal to a power y, what does it mean? It means that whenever the bases are same and there is equality between these two, so this will mean that the powers will also be same. Whenever a power x is equal to a power y, it means that x is equal to y. So this rule is very important because questions are there which will be solved by using this rule. That is an example, and this example we are going to simplify x power 1 by 4 multiplied by x power 3 by 4, and part B and C as well, by using the laws of exponents. Now taking the first part A, we see that the bases are the same. So whenever the bases are same, powers will be added. So adding these two powers, x power 1 by 4 plus 3 by 4, and then taking the LCM of these two powers. The LCM of these two is 4. So 4 is the LCM, and we are left with 1 plus 3. 1 plus 3 is again 4. 4 by 4 is 1. So that is x power 1. And x power 1 is again x. So this multiplication is equal to x. Now just look at part B. This part B has two variables, x and y. First of all, we need to separate these two terms in this fashion. We have written this division in this fashion, that is x square divided by x power 4 multiplied by y cube divided by y. We have separated x and y's. Now this is the rule that the bases are same, so and these are divided, so the powers will be subtracted. The same rule will be followed here, that these bases are same, so the powers will be subtracted. So that will become x power above power minus below power multiplied by y power above power minus below power. Here 1 is the power of y, so that is 3 minus 1. Now x power 2 minus 4 is minus 2 and y power 3 minus 1 is 2. Now x power minus 2 multiplied by y square can be written by omitting this multiplication sign, which is x power minus 2 into y square. C part we are going to follow the law of exponent, that this whole power 3 can be written separately on x and on y. So we have written separately this whole cube on x square multiplied by on y power minus 1 by 3 whole cube. Now this is the other law of exponents, that we are going to multiply these two powers and multiplying these two powers as well. So that is x power 2 multiplied by 3 and y power minus 1 by 3 multiplied by 3. X power 2 by 3 is 2 3s are 6, so that is x power 6, and 3 are cancelled, and we are left with y power minus 1, so that is x power 6, omitting this multiplication sign, y power minus 1 is the answer of this whole cube. So that is part C. Now in this slide we see that the question is, write down the values of x which satisfy each of the following equations. That is A part. We are going to find x whenever 5 power x is equal to 25 and 3 power x is equal to 1 by 3 and so on. So let us start the solution of this example. First of all, we are taken this equation, 5 power x is equal to 25. 25 can be written as 5 square. Now we see that bases are same, so it means that x is equal to 2. So x is equal to 2 is the solution of this equation. Similarly, taking this b part, 3 power x is equal to 1 by 3. 1 by 3 can be written as 3 power minus 1. We have shifted this 3 towards numerator to get 2 power minus 1, 3 power minus 1, sorry. Now we see again that bases are same, 3 and 3, so it means that powers will be equal. X is equal to minus 1, so x is equal to minus 1 is the solution of this equation. Similarly here, 2 power x is equal to 1 by 8. 1 by 8 can be written in exponential form as 2 power 3. 2 multiplied by 2 multiplied by 2 is 8, so that is 2 power 3. Now whenever we shift 2 power 3 in numerator, we will get 2 power minus 3. Again bases are same, so x is equal to minus 3 is the solution of this equation. Now part D, 2 power x is equal to 64. 64 can be written as 2 power 6. Multiply 2 6 times to get 64, and that's how we have made these bases same. Bases are same, so x is equal to 6 is the solution of part number D. Now that is part number E. 100 power x is equal to 10. 100 can be written as 10 square, and 10 square whole power x can be written as 10 power 2x. Again these two bases are same, so 2x is equal to 1. But we are in search of values of x. We need the value of x, so divide this equation both sides by 2. Whenever we multiply both sides by 2, we will get this equation. Now cancelling this 2, we will get x is equal to 1 by 2 is the solution of part number E. And the last part is 8 power x is equal to 1. 8 power x is equal to 1. We are going to make these bases same. We know that something to the power 0 is 1. So this one can be replaced by 8 power 0. We can replace this one by 4 power 0, 2 power 0, 5 power 0. But in this case, we need the base 8. So that's why we have written this one 8 power 0. Again, bases are same. So x is equal to 6 is the solution of this equation. So that is how we find the value of an unknown x whenever the exponential form is given to us. We first of all we make the bases same, then we take the powers equal. Make the bases same and take the powers equal to get the value of the unknown x. Now, in this coming slide, we are in position to define, to understand the idea of logarithm. We know that 8 can be written as 2 cube. What does it mean? 2 cube means multiply 2 3 times. 2 multiplied by 2 multiplied by 2 is 8. So 8 is equal to 2 cube. Whenever this is the exponential form of 8. 2 power cube is the exponential form of 8. We are going to convert this exponential form into logarithmic form. How could we convert this exponential form into logarithmic form? Write log on this side and make this base 2 the base of that log, and leave this power on this side. What does it mean? We have written log with 8 and make we have written log on this side and make this base the base of log and leave this power 3 on right side. It means that logarithm of 8 to base 2 is 3. Whenever log of 8 to the base 2 is 3, it means that 2 power cube is equal to 8. Let us practice this equation. We know that 9 is equal to 3 square. 3 square is the exponential form of 9. How could we write this exponential form in logarithmic form? We should write log on this side and make this base 3 to the base log and leave this power 2 on that side. So that is log to the base 3, 9 is equal to 2. Similarly, we know that 125 is 5 cube. Multiply 5 3 times to get 125. If we convert this exponential form into log form, we'll write log with 125 and make this base the base of the log and leave this power towards right side. So log to the base 5, 125 is 3. Similarly, 3 can be written as square root of 9. Square root of 9. Whenever we write this exponential form in the form of log, so we'll write log on that side and make we'll write log on that side. So we have written log on that side and make this base the base of the log and leave this power towards the right side. So that is the logarithmic notation of this exponential form. So that is the total definition, that whenever we want to write this exponential form in the form of log, we will be writing log on this side and write the base of log that side, and leave the power on right hand side. So whenever y is equal to base to the power, base to the power, we can write this as log to the base, this base, log to the base y is equal to leave this power towards right side. Now that is the difference between these two. Whenever we are going to convert exponential form to logarithmic form, so this exponential form will be given to us, and we will be converting this exponential form into logarithmic form. How could we convert this form to log form? We will write log on that side and make this base be the base of the log, and leave this power x towards that side. For example, if 9 is equal to 3 square, so this can be written as log to the base 3, 9 is equal to 2. So whenever exponential form is given to us, and we are going to convert this exponential form into logarithmic form, we will follow that rule. And whenever you are given the logarithmic form and we are asked to convert it into exponential form, how could we convert this logarithmic form into exponential form? Just drop this log from this side and bring this base towards that side and make x the power of the base. For example, if log to the base 3, 9 is equal to 2, so remove this log from that side and make this 3 the base of this 2 to the power 2. So 9 is equal to 3 power 2. That is an example that write down the following into logarithmic forms. Just look at here, we are given exponential forms in these questions. Exponential forms are given, and we are going to convert these exponential forms into logarithmic forms. So the first one is 5 cube is equal to 125. Rearranging this equation, write this equation in this fashion, that write 125 on left side and 5 cube on right side, and now convert this equation into logarithmic form. Write log with 125, and the base, we have written this base with log 125 is equal to leaving this power towards right side. So log to the base 5, 125 is equal to 3. Similarly, 2 power 4 is equal to 16. 2 power 4 is equal to 16. Rewriting this equation in this fashion, writing 16 on left side, 2 power 4 on right side, and convert this exponential form into log form. How could we convert? Log to the base 2, 16 is equal to 4. Similarly, the third question is 3 square is equal to 9. Rewriting this equation as 9 is equal to 3 square, and now convert this equation to log form. Log to the base 3, 9 is equal to 2. Similarly, the last question, 1 by 2 whole cube is equal to 1 by 8. Rewriting this equation in this fashion, and now convert this into log form. So that will become log to the base 1 by 2, 1 by 8 is equal to the power 3. So that's how we convert exponential forms into logarithmic forms. Now in this example, we will write these logarithmic forms into exponential form. In the previous example, we have converted the exponential form to log form, and now in this example we will convert the exponential form into we will convert the log form into exponential form. So how could we convert log to exponential? The first question is given to us. we are going to remove this log from this side. How could we remove this log? If you remove this log from that side, so convert this base towards that side and make 3 the power of 5. So 125 is equal to 5 cube. So that is the exponential form. That is very easy. Number 2, log to the base 216 is 4. Removing this log from this side, so we are left with 2 power 4. Similarly, question number 3, log to the base 39 is equal to 2. Removing this log from that side, so we are left with 9 is equal to 3 power 2. And the last one is log to the base 1 by 2 1 by 8 is equal to 3. So removing this log from that side, we are left with 1 by 8 is equal to 1 by 2 whole power 1 by 3. So that's how we convert the logarithmic notation to exponential notation.